Leo, can you hear me?
Yes, I can hear you.
Okay, yeah, I apologize for that. The system went down and it's been a nightmare trying to log in. So should be good to go. Okay, cool. Okay, let's try this again. Welcome,
I know.
Angel, you said? Okay. Angel, are you a vet?
Yes, I am.
Okay. Well, welcome. With this. I have a few things happening today. You know what's on. You guys know. All right, so we got a lot to do today. Apologize for the late start. Started downstairs and I came up here and. Nice. Okay, before I start, you got any questions? About everything?
I mean, I don't have any specific questions, but I don't really know nothing about this.
Statistics?
Yeah.
Don't worry,
Okay.
we'll be all right. Okay, so last weekend, did you miss too much last week?
I feel like I did. Okay.
Nah, you were able to catch up pretty quick from last week's class.
Okay.
Just make sure you review the PowerPoint and it should be pretty straightforward. If you got any questions, just email me or
Okay.
I'll answer whenever I can, okay?
Okay.
Real quick, tell me something about yourself. Where you from?
I'm from Jersey.
Okay, all right.
I'm a wig maker.
A wig maker?
Mhm.
Interesting.
Yeah.
All right, well, how did you get into that?
I just started making wigs. I just started teaching myself how
Nice.
to make some money outside of the Navy.
Okay, all right. So you out of the Navy now?
Yeah, I'm out.
Okay, all
Yeah.
right. Okay, well, you okay? I'm from New York, so
Okay.
well,
That's nice. That's nice.
you be all
I
right.
love the East Coast vibe.
Yeah, you be all right. You be okay. Okay, so this week what we're doing is we're talking about measures of center and measures of dispersion. Okay, so don't let the word scare you. Don't let any of the symbols and all that stuff scare you. What I will say about the symbols from this point forward is to try to familiarize yourself with the statistical symbols. Okay, once you understand the symbols, it becomes much easier to understand the statistics. All right, so when we talk about a population, um, usually if you talk about population, so population, a sample, okay? So the whole point of statistics is to gather data, analyze it, then after that, you kind of visualize it, right? You kind of put it in a context to where people can understand, you can talk to it, you can brief it, you can, tell people, oh, 40% of America does this or whatever the case may be, right? Just like we had the elections yesterday, across the nation, all that was statistics with the polls and all that stuff, right? So when we talk about a population, think of a population as just being a group of anything. Okay. All the chairs in here is our population of chairs, right? Don't think of it as a person, right? So when we talk about population, most population statistics or parameters are going to be a Greek symbol. Okay. So for us, let's just say we're looking for the mean. Okay. And the mean is just a fancy word for average. Okay. And so we're looking for the mean. The population mean looks like a funny Greek U. Okay, that's when we say, okay, I know they're asking the population. A sample mean is just an S. Actually, it's not S. You're gonna take that back. It's X bar. Okay, so it's basically an X with a bar on top of it. Okay, all that's saying is, hey, look, I want you to give me the average of the sample. I want you to give me the average of the population when you see this. Okay, so when we talk about population, again, just think of it as a pizza. There's a bunch of slices and you want to know what the pizza's about. So you grab a slice, which is considered a sample. Easy enough? Straightforward? Okay, cool. So we talk about mean, right? The next thing we talk about is the standard deviation. Okay? Don't mind my ink, my shoddy writing. Standard deviation, it's this and then this, okay? So just a funny O with a little tail at the top and then lowercase s for sample, okay? So when we talk about standard deviation, all we're looking for is what is the difference of the data set? So let's just say we have a data set like this, 10, 12, 13, 14, right? And then I take the average of that data set, right? What I want to know is what is the difference from the average compared to each individual data point? Right? It just matters, it's just looking for the spread, right? How far apart are these data points, right? Because the more, the closer these data points are to each other, the more likely that the population is the same or the sample is the same. The further out they are, more likely that they're not the same. They're not came from the same place. So for example, if I had a bunch of NBA players in here, right? And I took their height, right? 6'5", 6'6", 6'7", 6'4", 6'3", whatever, right? You pretty much assume that all those guys are in the NBA, right? But then you take my height, I'm 5'10", right? You're like, this one's a little odd, right? He's 5'10", even though NBA players are 5'10", 5'11", but nonetheless, it doesn't fit with the rest of the data, right? And so you would know that, okay, maybe this guy's different. Maybe he's not an NBA player. Maybe he's a coach. Maybe he's something else, right? He could be a player, but he's not falling within the kind of the average of everyone else's height. Okay. So that's what we're really talking about when we talk about standard deviation. We're looking for the dispersion, right? How far apart are the data points from the mean once we calculate it, all right, whatever it is. So just keep in mind that when we talk about anything statistical, we always have to have a mean and we have to have a standard deviation. Because I need to know what the spread is between each data point and I need to know what the average is, all right? Because that's the only way I'm gonna be able to calculate below and above, or above and below average. Okay, that's really what we're trying to do. We're trying to figure out, okay, this is the average height, right? Everybody knows the average height of a woman, average height of a man, right? But what's considered above average, what's considered below average, right? And so that's how we do it. We do it through all statistics. But I really want you guys to key in on the symbology, right? I put a link in the Moodle to a PDF in week 2, it should be in week 2, that help you out with the symbology. Just take a look at it. There's a lot of different stuff on there, right? Just kind of stick to the stuff we're talking about, population sample. We'll get into some other things, right? But for the most part, make sure you understand the difference between a population and a sample, okay? Because that will make a difference between you understanding the question and answering it properly and you getting it wrong, right? There is a difference as to when you calculate the population mean and when you calculate the sample mean, okay? So keep that in mind. But the symbology is important to understand, and it'll take you a little bit, reading it over and over again, using it to figure it out, okay?
This looks familiar
Okay,
from
good.
like high school.
Yeah. I mean, a lot of people take it in high school and kind of, don't look at it again because it's not necessarily something that most people use on a day-to-day basis as far as, you know, their everyday things, right? They don't think about it, but you use statistics every day, whatever you're doing, right? You're making wigs, all right? What's the average number of strands you gotta put in a wig, right? What's the average number of hours you take to make a wig, right? It depends on the size of the wig, right? The type of hair you're using, got the different glues, different type of things, right? How long is the wig gonna last on average? I know customers may ask you, well, how long is it gonna last? Well, give or take, it usually lasts a year if you take care of it, X, Y, Z, right?
Something about some hair.
No, I don't know anything about hair. There's just an example.
I thought he was gonna say something really off.
No.
You said the glue. Right.
No, I got a sister, I got a mom, got cousins, I got a girlfriend, so, them kind of things, you gotta pick up on those things, right? So, but at the end of the day, right, understanding the symbols, knowing what the symbols stand for, right, will make it a lot easier for you, right? So take a look at that reference I put. You gotta check it out already?
Yeah.
Okay, yeah. And there's, like I said, there's a lot of different things on there.
The
Don't,
formulas look intimidating.
don't worry about the formulas. We're gonna get through them, right? The highest level math you're gonna do here is maybe algebra tops, maybe, right? Everything else is pretty much understanding the order of operations, right? My dear Aunt Sally, whatever, parentheses, exponents, that kind of thing, then
PEMDAS.
PEMDAS, yeah, exactly. Get that down, remember, refresh your memory on that, you'll be fine. Right, everything else as far as the math, the hardest part to understand is probably the sigma, right? Which just means sum, which is the big E, right? You see sigma is just the big E, right? It just means adds everything up. That's all it means, right? And
Do we have to know how to do the standard deviation,
yes,
like calculated?
yes, you will know. But to be fair, when you really do this stuff, you don't do it by hand.
Oh,
You
okay.
put in Excel, for kind of lower level stuff, but there's programs out there. There's some program called SPSS. IBM makes it, and it's a really high powered level program that statisticians use, and it does everything, right? But for the purpose of the class, we're gonna go through some examples, okay, and how to do it. And it's not difficult. We'll walk through it. We'll take it easy, nothing complicated, right? Again, understanding the symbols is the hardest part. And once you get the symbols down, it's a basic, plug and play type thing, and you're off to the races, okay? You have to understand after that, what is it telling me, right? That's really the point, right? What is the standard deviation saying to me, right? And this is why I don't necessarily use Excel in the class, because I find that people know how to use Excel, they'll put their little inputs in, but then when they get the answer, they don't know what it means, right? As you do it and you understand the process, you understand what's going on, you'll understand, oh, okay, this output means this, right? And then you really use Excel and some of the other software to make it easier for you to go, right? So don't be intimidated by any of this stuff, all right? And we're gonna go fast, okay? So it's gonna be incumbent upon you to go back home at some point, and take a look at this stuff again, all right? You're not gonna get it the first, tonight. It may refresh your memory, but you're gonna have to go back and one thing at a time. All right? Don't try to, and I may spread this class over 2 classes because it's a lot of information and I don't want to force too much until your brain explodes. You're like, okay, this is too much information right now. Okay, so I'll take a look at your eyes and you go glazed over and like, all right, Dr. K, I'm done with you. Then I will stop. Okay, so nothing really big here to see. This is just the authors giving you an example of, kind of investment decision, because this is a business statistics class, right? We're gonna talk about some basic statistics that they use in business, right? This is not something that we're gonna get too in depth in as far as real statistics and calculating everything, right? This is why, you'll see a lot of the Excel functions in here and that kind of thing, because again, for the most part, use Excel or something called R, right? But R is kind of somewhat high end. A lot of engineers use it, that kind of thing. And SPSS is the other platform, and Minitab, right? So again, not a big deal. Now we have Chat GPT and all this other stuff, so you can use that also to help you out. My recommendation is if you really don't understand something, you need some further explanation, go to YouTube. YouTube has great, people that probably explain it better than me can, kind of, sometimes just need to hear it from somebody else and it kind of clicks, right? So I don't take offense to that, just everybody learns differently, all right? Okay, so measures of center, right? So whenever we talk about measures of center, we're really trying to figure out, okay, what is the middle, right? What is the average of this data set that we're looking at, okay? Anytime we talk about measures of centers, we're talking about, how do I figure out what the average is for this group of data set, right? And these data points, right? Or the median, all right? So the arithmetic mean, again, is just another name for mean or average, okay? So don't be, intimidated by that. All right, so first formula we're gonna get into is the mean, right? Or the average. Without even looking at this, I know you guys know how to do the average. You add them all up, divide by number of data points you have in there, whatever numbers you have, and then that's your average, right? Same thing. Mu is how you pronounce this, right? This little funny U that I've drawn on the board. This is the population mean, okay? It's called mu. You got your sigma, means add everything up, and you got your X, right? And the X is just the data points within your data set. So the 10, 12, 13, 14, this is the X, right? So the notation really is important to get so that you don't get confused. Don't worry about the I, what's I in math? Anybody remember?
It's an imaginary.
Imaginary number, okay? It could be anything you want it to be, all right? And so you'll find that in math, you'll see, you'll see X1, X2. Don't let the subscript throw you off. It's just saying, hey, there's 1, 2, 3, 4, 5, 6, 7, whatever. But I is used to say that, hey, whatever number you have, that's what it is, okay? So, use a parameter describes the population. Here we have the sample mean, right? Same thing. There's no difference in the formulas, right? If you notice, right? Same formula, different, asking for different things. Population mean, sample mean. Okay? So the sample mean is just X bar equals the sum of X's divided by N. Notice that the N is lowercase. Okay? N is just the number of data points in your data set, right? No matter if it's capital, no matter if it's lowercase. Okay? N will always represent the count. All right? No matter what kind of math you're doing, where you're at, X and N typically stay the same. X, N, and Y pretty much typically stay the same, okay? So X bar statistic describes the same, all right? Okay. So the next thing we talk about is growth and value, okay? So one of the most important things for most companies that, especially investment companies or brokerage firms, they're trying to, get customers in and clients in. And then the first question is, what's my growth gonna be? What's my return on investment, right? I put $1 million in, what should I expect in a year or two? Or if I risk $1 million here, what's my reward, right? So you gotta have the reward to risk ratio or risk to reward ratio, right? You try to figure that out. So the growth here is just basically the mean return for growth and the mean return for value, right? Let's go back here real quick. Let me see. So these numbers here, they're using it here to calculate the average. Okay? So we just calculating the average here, divided by 36, divided by 36. So the average is 15.775 on the growth, and the value is 12.005. Okay? So pretty straightforward when you're looking at the average or the mean. All right, so not a big deal. All right, so over a 36-year period, the mean return for growth was greater than the mean return for value. Okay, so basically, growth was better bet than value. Okay, and so we're talking about growth and value. We talk about kind of like blue chips, right? When we talk about value, we talking about like if you want to put in the context of stocks, Microsoft, Apple, right? Because those companies no longer, not they're no longer growing, but they've kind of tapped out on where they're at, right? So what they're really giving you is sustained value, right? Over time, they will grow, but they don't really have any more room to really grow exponentially, right? They've gone through that cycle already. So now they're at the value point where, hey, if you buy this in 10, 15 years, it'll retain its value and it should increase in value, right? Growth is something where we would look at something like Bitcoin or something that is new, right? How much growth potential does it have? AI, right? We're looking at the growth of AI, right? So if I put $1 million into Bitcoin or some other coin, right? How much do I expect it to grow? All right. And is that amount of money worth it for me? All right. Because there may be an opportunity cost to that. I may be able to invest my money in something else and get more of a return. Okay. Or maybe grow faster. All right. So that's just one thing. All right. So another example here, administrative salaries, right? And you're just getting basically all the means for this, right? So you could just add all this stuff and that'd be it. Okay, add it up, divide
So
it.
this whole thing is just getting the average?
Yeah, these so far.
Oh, okay.
Yeah, so
That's
far.
not the whole, okay.
No, it's not the whole thing. Yeah, that's just the beginning, right? So again, like I said, two pieces of data or two pieces of information you need, the mean and the standard deviation. If you don't have those two, you really can't do anything. All right. Now, there's different ways to get each one if you don't have one, right? If you have the mean but you don't have the standard deviation, there's a way to get it. Right? If you have the standard deviation but don't have the mean, there's a way to get it, right? But those are formulas and you kind of have to kind of go through, understanding what's going on, all right? But for the most part, Right now, we're just talking about the average, right? So we just get the average salaries for all these positions within the company. And then this value is not reflect typical salaries. Okay, whatever. So not important, right? Becomes important when we start looking at maybe, okay, who are we gonna fire first? Okay, if the average salary is 50,000 and the senior data analyst is making 100,000, you might think about chopping him or her, right? Because I can, he's twice the average salary, right? Maybe I can get somebody for 75,000 instead of 50,000, instead of 100,000, okay? So those are the kind of decisions people start making. Now, they wouldn't do that with just the average, okay? You're talking about, really looking at different factors, different things, do we have, the manpower, what projects do we have coming up? Is this somebody that we need, right? So it's different things that go into, but just a basic, thinking about, hey, the averages we have and look at the salary, right? Like it says, 6 of the 8 employees earn less than the mean, okay? The thing that is not confusing, but throws the mean off and doesn't make it really a very good indicator of the center is because it's easily impacted by outliers, right? And outliers are, again, numbers that don't fall within the data set, right? Same thing with 5'10", everybody is a 6'4", 6'5", 6'6", right? My 5'10" is gonna pull down the average height, okay? And so, yes, we wanna include it, or we wanna highlight it, take it out, calculate it, calculate the average without it, and then be like, okay, hey, there's a note, hey, we did have somebody who's 5'10", but we kept them out because it was gonna pull down the average height, right? Just like the example I used last week in class. If Shaq comes in here, all 7'1" of him, and we try to get the average height of the class, we all gonna be 6'4". 6'3", right? Because of Shaq, right? Nobody in his class is 6'3", 6'4", right? Because of Shaq and his 7'1", he throws off the average, all right? So this is why average a lot of times, if you ever watch the news and you watch and they say the median income or the median number of people in a house, that's because the median is the actual middle of the data set. Okay, and that is more accurate as to what the center is, right? So if you look at this data set here, 10, 12, 13, 14, okay? We would take the average here, right? What's the average here? You know, 22, 25, no, 35, excuse me, and 49? Is it 49? Divided by 5, what is that? That's 9.8? Okay. Okay, so now 9.8. Okay. So when you look at that, is there,
Wouldn't it be over 4?
oh, excuse me, or 4, yeah, you're right, thank you. See, I was like, that doesn't make any sense, none of it matches. So it's
12.25.
12.25?
Mhm.
Okay, that's better. I was like, none of it falls under it at all, right? Thank you, good catch, all right? So 12.25, right, is the average of this data set, right? So we can see 12.25 falls in between 12 and 13, so, okay, fair enough, right? Now let's take the median, okay? So the way you calculate the median is that usually in this situation, because it's an even number of data points, you have to take the middle two and you take the average of those two. Okay, the 12 and 13. So of course that's what, 12.5, all right? 12 and 13, 25.
Yeah, 12.5.
12.5, right? So 12.5 is the median. Typically, if you had, so when you have an odd number of data points, you literally take the number in the middle. You put them in order, and you take the number in the middle for the median. If you have an even set of numbers, you take the two numbers in the middle and you take the average of those numbers, and that's your median. Okay? So in this situation, the median and the mean, right? We got the mean here, we got the median here, okay? They're not too far apart. Okay, so relatively speaking, we're pretty good, right? But that's because we have a small data set. also, and you know, the way I wrote the numbers, they're pretty close, right? So they're not too bad, but you will usually see on news reports, on most real research, they will speak about the median, but we will use the mean for calculations. Okay? Because the median is just, it's easier to understand. It's easier for me to show you. Come on, Richard. It's easier for me to show you the mean, right, than it is the median, right? Because sometimes the median doesn't necessarily pan out. You gotta do some math and all this other stuff, right? But um, this is just basically the basic measure of center, right? Okay, we just talked about the median, right? If the middle value of n is odd, we take the average of the two middle numbers, okay? If it's you have an even set of what you call it, numbers, you just add up the middle, okay? And you get that. If it's odd, you just take the middle number in the middle. All right? Easy enough? I know it's a lot, okay? Just tell me to slow down if you need me to. All right, come on. All right, so middle value if it's odd, average of the two is even. Good? Okay, all right. Okay, so let's see here. This is just a calculation of the median, all right? So we're not gonna waste too much time on it, okay? So as you can tell, we have 8, and so that's an even number. So we take the two middle, we take the 4 and the 5, right? The 90,000 and 100,000, and we take the average of that. And so the median is 95,000, okay? Four sides less than 95,000, and four sides are greater than 95,000. So we're good compared to the mean of 147,500. The median better reflects the typical salary, right? Because most people are not making $147,000, right? But this is more representative of what they're really making, 95,000. Okay. All right. The mode is just basically the most frequently occurring data point. All right. So let's have something like you can have unimodal and bimodal and multimodal. All right. So let's say I got something like this. 5, 10, 10, 15, uh, 15, 20. Yeah. Okay. All right. So 10 occurs twice, 15 occurs twice. Okay. This is what we would call bimodal. Okay. Because it has two numbers or two data points that repeat themselves exactly the same. Okay. We could also have something like this 1, 5, 6, 6, 8. Here we have the 6 that repeats itself and it's the only one. So this is the mode, okay? 6 is the mode here, 10 and 15 are the modes here, which make it bimodal. This is just unimodal, okay? And then we can have something where we have multiple, repeats, okay? So what you're really looking for with the mode is just like which number repeats itself the most, okay? And it's usually used for, what we call categorical data, which is basically description, right? It's a hat, it's a car, it's not a number for the most part, right? Anything numeric is quantitative, anything categorical is usually qualitative, all right? All right, so the mode's pretty easy, and for the most part, you're not gonna deal with the mode because it's such a antiquated way of looking at things, and they don't really ask it. They teach it just so you have a way to measure categorical stuff. Okay, so you can tell here, size of women's sweatshirts, small, large, large, medium, small, large. So basically, the two sizes are small, medium, and large. Small and medium appear 2 times each. Large appears 5 times. The modal size is L, right? Is large, right? Because it appears the most times out of all of these, right? So L is the mode. Okay. All right. All right. So here are the Excel functions for you guys that use Excel. You may want to use Excel just to kind of test your math or just see if you're accurate or not. Okay. So take a look at it. We're not gonna, skewness, ketosis. Don't worry about ketosis. We're not gonna redo that. All right, we'll leave the rest alone, but just be familiar with these, right? And what they each mean, right? In case you use Excel, this is how you write it in, okay? In Excel, if anybody, who hasn't used Excel here?
I think I.
Yeah, I'll say, I know you have, for sure. Bianca, I don't know if you have, a little bit, I'm saying you have. Yeah. So Excel typically, there's a tab at the top for the math, and it has a statistical drop down. And then once you press the statistical drop down, it'll, once you type in whatever you want to type in or you look for it, it'll pop right up. Okay, and you just click on it and it'll populate the cell. And what you have to do is this array just means what are the numbers? What's the data set that you're trying to use? Okay, that's all array means, right? What are the numbers? What's the information you're trying to get me? You want me to get the average, but of what? All right, that's what array means. Okay. All right, so that's just an example of the Excel output based on the example data set that they have in the book. Okay. No, we're not doing R, so don't worry about that. We're not doing that either. Don't worry about it. Okay, so something near and dear to your heart, the weighted average. Okay, so anybody know what the weighted average is? No. Use it all the time. All right. I'm sure you're gonna use it here in a couple weeks. All right. So all the weighted averages is the mean, right? Sum of W, the weight, times the sum of the X, which is the data point, right? So the X bar, which is the mean, is what we're trying to calculate. And basically all that means is, hey, think of like when you're trying to calculate your grades, right? I want a 90. I want a 95. What do I have to get on my assignments to get a 95, right? Well, you might need to know the weight, right? Your final paper is 20% of your grade. The final exam is 15% of your grade. The LEs are 2% of your grade, right? So the weight, right, is that percentage multiplied by the score you actually get. So basically, all you're doing is really saying, okay, if I know my grade is 20%, and this final is 20% of my grade, right? Based on my grade, I know how many points I have gotten out of that 200 points for the final, right? It's 20%. Did I get all 200 points? Did I get 150 points? Whatever it is I got, right? And so the weighted average is used to calculate, right? Based on a weight that's added to it or bias, right? That we call it typically, right? All right. So perfect example. Student scored 60 on exam 1, 70 on exam 2, 80 on exam 3. What is the student's average score for the course, right? If the exams were 25, 25, and 50, okay? And so what you're just trying to figure out, okay, what's my average, right? You got the first weight, second weight, third weight, right? And then here you have the average that you're looking for, right? The mean, right? 0.25 times 60, which is the first score in exam 1, right? Multiplied by the weight. The second, multiplied by the weight here, times the score you got on the second exam. And then here, 0.5, that's the third weight. And you got an 80 on the third exam. And you do the math, and then boom, you get your average, right? That's your grade, right? Note done weighted mean is only 70, right? If we were to not use any weights and we just to do a straight line, this average, it would average out to 70, okay? If we didn't use any weights, right? But we use weights in class. We use weights to determine grades, right? Because everything is not equal. Learning engagements are worth one thing, but your final exam and your final project are worth something, or they're worth more, right? If we're trying to give more weight to something or less weight to something, right? So when we talk about that, we're really talking about what is the contribution of that particular data point to my outcome, is what we're really getting at. If I'm making a cake, let's say I'm making an omelet, okay? Are eggs important for an omelet?
Of course.
Right? So that's probably gonna have a really heavy weight, right? Let's say 90%, right? 90% of it is you need eggs, right? You could also buy the little liquid eggs in the bottle or the little container, right? The carton, right? Right? But for the most part, you need eggs, right? What else do you need to make an omelet?
Vegetables.
Vegetables, right? A pan, right? So that could be 0.5 or 5, that could be 5%, right? In your pan, right? Give it away, like, okay, can I make eggs some other way without a pan? Sure, I could. There's other ways to do it, right? But more than likely, no, right? But at the end of the day, just for example's sake, we'll say, yes, you can make it some other way. But in this example, we'll say the pan is worth 5%. The veggies, the salt, the seasoning, another 5%, okay? And so I wanna know, can I make an omelet, right? If 90% of it requires, whatever, the eggs, and it's 2 eggs, right? 3 eggs, depending on how many, how big I want my omelet to be, right? Whatever the case may be, right? So that's all I'm trying to figure out. I'm trying to give certain things more weight or more emphasis than other things, right? Some things have more importance to you than other things in life, all right? Okay, so if you're giving the weight to, hey, me coming to class or me staying home, right? You're gonna give more weight to coming to class because that is going to contribute to your eventual outcome, right? So that's just the weighted average. Pretty straightforward and simple, okay? Um, distribution, all right? So definitely gonna need example, right? All right, let me see something. It does here. All right. So when we talk about distribution, we are looking at something like this. Everybody good with this? I'm gonna take it off.
Yes.
Okay. All right, let's talk about distribution here. Everybody's heard of the bell curve?
Yeah.
Something like that? Okay, well, we'll figure it out. By my art skills, but not, okay. All right. Got one. Here, too far, but. Okay. Mhm. Okay. This is what we call a normal distribution, okay? There's a better illustration of it, but I need to use this so I can explain it to you, okay? This is what we call a normal distribution, a bell curve, right? Or Chebyshev theorem, okay? Some Russian guy came up with this, super smart guy, whatever, okay? So when we, as researchers, or just as looking on in general, right? Everyone is basically the same, right? We talked about this last week. 95% of us are on the same sheet of music. Okay? We are pursuing happiness, we're pursuing love, we're pursuing just being left alone. We're just pursuing things, right? We all do things the same way. We eat the same, we use the bathroom the same, we shower the same, we have to groom ourselves the same, to take care of ourselves, right? The same thing that afflict one group of folks afflicts another group of folks, right? Maybe not the same degree, but at the same time, you know, a bullet doesn't matter. It has no name on it, right? Bullet will kill you as quickly as anybody else. Okay, so most of us are all up in here. We're all in the middle. Okay, we're all in the middle here. But then you have the people, the 5%, who are not necessarily average. Okay, so we're gonna go back to the height thing, right? On average, everyone kind of falls in here, right? Average height of a woman is what, I think 5'5" now, maybe 5'6". Average-
5'7".
5'7" maybe, right? Average height of guy is 5'10" now, I think, or maybe 5'11".
No, guy is 5'7" and woman's like 5'2", something like that, 5'3".
Is it that gone? You sure?
In
Yeah,
America?
Yeah, I'm about to say, I think that's bumped up. When'd you look at that?
in the United States.
Yeah, when'd you look at
Yeah,
that?
yeah, look, average.
What we got? Let's just,
Height of man.
we'll do some real time fact checking.
5'6" for male and 5'2" for female.
Wow, dang,
Yeah.
tiny people. It's all right, it's all good. 5'2", 5'6", okay?
Yeah, I'm way above average.
Yeah, you're good, you're living the life, okay? So, alright, so the way we tell that they're below or above average is by understanding the average, right? So here, to the left of the zero is below average. To the right of the zero is above average, okay? Now, here is the tails, and this is where we say below average at this point right here, and this point right here, we say above average. So everything here and beyond is above, everything here and beyond is below, okay? So think about someone who's 5'6", all right, as a male, all right? He is in here. But once you get to 5'5", they're in here. Okay, so think of this as 2.5% here and 2.5% here, okay? So this whole thing here is 95%. You have 2.5 on the below, 2.5 on the above, right? Which gives you 100% or 1, which is the whole, okay? Now, this here at the bottom, right, is our standard deviations, okay? So again, understand standard deviation is that we want to know how far the data points are from the mean, right? The mean from a theoretical standpoint is always 0. That's our starting point. The standard deviation is always 1, right? Because we're always going to be 1 standard deviation away, right? We're always looking for that, okay? So 1 standard deviation away, right here, 2 standard deviations over here, 3 standard deviations goes out, and you go to how many deviations you want, but usually after 3 standard deviations, that's considered outlier, right? Which is something that doesn't fit at all with the data set. Like Shaq come in here, Shaq would be an outlier because he's 7'1". Nobody here is even close to that, okay? So he's an outlier within our group, right? But this is what we would call symmetrical. Okay, this is symmetrical, also known as the normal distribution. Okay, normal distribution is symmetrical, meaning that it's got a little bit here, got a little bit here, but in the middle. It's real pretty. Okay, nice and even. You know, everything fits, works. You know, it's like you got 2 ears for the most part. We are symmetrical. All right, both our legs usually are the same length. Right, arms the same length, teeth, all this stuff, eyes, right? Very symmetrical. All right, so this is just symmetrical. You can also have something like this. All right, and this is what we call skewed. Okay, and it's the way you can tell how skewed it is if the little part is on the right side or to the right of the zero or the right of the mean, that means it's positively skewed. If it's like this, and this part here is on the 0 here, the 0 here. And this part is to the left of the 0, that means it's negatively skewed. Okay? Keep this in mind. Okay? This is on each side of the 0, you know, it's a negative, right? And it's a positive, right? It's symmetrical in nature, right? This here is negatively skewed, this is positively skewed. We don't necessarily want skewed data. Okay? But we do get skewed data sometimes, right? But there's a way to fix it. beyond the scope of this class, not something we're gonna talk about, right? But understand that you have to know, like, okay, this is negative skewed because of the tail, this is what we call the tail, right? Because it's to the left of the zero, it's negative skewed, because it's to the right of the zero, it's positive skewed. Okay? Now, let's see. So, standard deviation, okay? When we look at the standard deviation and also the negative numbers or the negatives, right? The negatives don't have any value. Okay? The negative denote direction. Okay, if you see a negative, that means it's below or to the left of the zero. If you don't see anything, just positive number, that means to the right of the zero. Okay? And this will be important when we talk about correlation. And we talk about how things are correlated, and they're negative correlated, positive correlated, right? That kind of thing. But just so you understand, like this has no value. It's negative here. It just tells you which way it's going. Okay? So you understand. So if you see a negative in front of the number and we talk statistics, just know that whatever it is below average. Okay? Or it's, you know, the standard deviations are below average from the mean. Okay? All right. So, okay, I think that's good for right now. All right. All right, so zero observations of evenly distributed on both sides of the mean, symmetric, positive, extreme observations in the right tail, pulling the mean up relative to the mean, negative, extreme observation left tail, pulling the mean down relative the median. Okay, so again, positively skewed on the top, negatively skewed at the bottom, no skewness, normal distribution. What we want to see symmetrical at on the left hand side. Okay, again, I know it's a lot. Take your time, digest it when you get a chance, okay? Take a look at it. We won't do my clicker, oh, there it is. All right. All right. What is this? Oh, okay, so percentiles and box plots, right? So everybody's familiar with percentiles, right? You're in the 5th percentile, 10th percentile. Your kid is in the 50th percentile, right? Or the 75th percentile, whatever the case may be, right? All it is trying to position or locate where you fit within the grand scheme of things. Okay, when we look at percentiles. All right, so approximately 1 minus p% of the observation are greater than the pth percentile. Okay, measure of location only uses a measure of relative position because it's easy to interpret. All right, so I'm not going to go too much into that detail. Really, it's better just to explain it to you. Right, so 25th percentile is quartile 1, 50 percentile is quartile 2, and 70 percentile is quartile 3. Okay, so when we're trying to figure out where do people fall into, you know, a certain category, do you fall in the first percentile, second percentile, third percentile, oh, third quarter, Q1, Q2, or Q3? Okay, so what we really need to figure out is, okay, what is the IQR, which is the interquartile range or the quartile range, right? Basically, what's the middle, right? Once I figure out the middle is, then I can tell whether or not you're in the 25th percentile, the 50th percentile, the 75th percentile. Okay, so we break it up into quarters. And the way you get the IQR, which is the interquartile range, is Q3 minus Q1. Okay, whatever Q3 might happens to be, right, minus the Q1, right, that will give you the interquartile range. And then once you get that, you know exactly where the middle is of your data set. Okay, and then you can say, well, if this person is, you know, the 25th percentile, right?
So when you get the IQR, that's when you know where the middle's at?
Yeah, yeah, Q3 minus Q1. Okay, that'll give you the middle.
But that's basically the range, right?
Yeah, basically, yeah. At the end of the day, yep. Because all it is saying the same. If you look at 75th percentile minus the 25th percentile, it gives you 50, the middle. Okay, that's really all. At the end of the day, that's what it boils down to. All right.
So could you use that to find the mean? No, right? Or just
Um,
the median?
You can find the median, yeah, you can find the median for sure, but it'd probably be easier just, I mean, you'd have to look for it, like physically look for it, but it kind of gives you like, okay, where do you fall as far as the percentile, right? You fall within 50% of the top tier, you fall within 75% of the top tier, right? Colleges use that all the time, right? Or they use it for determining, the growth of babies and that kind of thing, right? You're in the 10th percentile, 25th percentile. So here we have an example. We got Q1, Q2, Q3. We have the minimum and we have the maximum, right? So you kind of need those numbers, right? It's called a 5-number summary, right? Where we want to see what the max is, we want to see what the minimum is, right? And then that way we can determine what the middle is, right? What your average return going to be, or where's your average going to fall, right? Within the returns, right? And so we have to understand what's the first quartile, right? What's the lowest point, not the lowest point, but one of the lowest points that we have, and what's the one of the higher points that we have within the quartiles. All right. Let me see what they did here.
If you want me asking, there's never gonna be a Q4?
No,
Okay.
no. It's because it's just understood that the end is the Q4. All right, so Q3 basically exhaust all the way till the end.
Okay, thank you.
You're welcome. All right, so when we look at the IQR, right, this is called a box plot, right? This is just a different way in which to graph your data, okay? So once you figure out what the IQR is, right? The median, right? That's like we talked about, okay? Here it is, right? Q1, Q3, and then you subtract those two and you get the middle, okay? From there, you have this thing called a whisker, right? And you have this bar, boom, whisker, and bar, okay? So the minimum here, right, which was the minus 40, all right? And then the maximum here is not labeled, but this is the max, this is the min, right? Notice there's an outlier here, okay? There's a number that exceeds the max number, right? The average max number. And so we need to denote that to let them know, like, hey, there's a number here that's a little strange that doesn't fit within the data set. We need to look at that later, or whatever the case may be, or we need to highlight that so people know, right? And so 1.5 IQR, 1.5 IQR, that's basically saying you have your distance, right? It's always gonna be 1.5 IQR because you have your middle and you have your whole like Q1 here and Q3 here, okay? So just know that it's always 1.5 when it comes to the IQR as far as the constant factor that we're gonna use, all right? And we'll get into an example here in a minute. Okay. Okay. All right. So again, something that you won't be able to generate this in Excel. It doesn't do that. All right. But again, you more likely not going to be using IQR very often. All right. So keep that in mind. But here, we kind of talked about this earlier. I'm not going to discuss this too much. Okay. So let's kind of go through a quick example, all right? Determine whether any outliers exist. Repeat for value. Is the distribution for growth symmetric? If not, comment on skewness. Repeat for value. Use R to construct box plots, right? Because we can't do it in Excel. Like I said, don't worry about it because we don't have R. You can get a free version of it online, right? But I don't recommend it because you're not going to use it, all right? Okay. So the first thing we need to determine, right, in order to build our percentiles and box plots is the IQR, okay? So based on the data that gave us, IQR is Q3 minus Q1, quartile 3 minus quartile 1. Quartile 3 was 36.94 minus quartile 1, which is 2.86. So the IQR is 34.11, right? Basically, that's the middle, okay? That's the median, right? Our limits now, right? Our left and right limits, okay? 1.5 is our constant times the IQR, okay? So what we're looking for here is just the max here, okay? So we got 1.5 times IQR, 1.5 times 34.11, this is 51.17. So that's the max, go ahead.
And you said it's the limits, like the max and like the outliers, like the,
So the outlier is gonna be to the right of, well, it could be to the right or the left, but basically it's the data that doesn't necessarily fit in with the rest of the data, right? And so in this example here, right, the outlier is out here, okay?
Mhm.
But it could easily be out here too. It just depends on what the data says, all right? There's no rhyme or reason, it's just depends on what is you're given.
thank you.
No worries. Alright, so now we got Q1 minus the minimum because we need to get the left whisker, right? We need to know what the least, or the range, the low point of the range, right? So we have 2.86, right? Which is the Q1 minus the minimum, which is negative 40.90, which was given to us on the table, okay? Equal to 43.76. So that's your left whisker. Okay, that basically is the left side of the box with the long extension. Is this part. Okay, so right here is that number. Okay. Right, so the max, right, minus Q3, because we need to get the right whisker, right? 79.48, all right, minus 36.94 equals 42.51. So that's your right whisker. That is your right extreme. Okay, you got your left whisker, you got your right whisker. So now you have on either side the little box plot, all right? You got your whiskers. Both are less than 51.17, no outliers, right? Because we got the limit, right? We calculated the limit, 51.17. All right. So we know that's as far as it goes, as far as like, okay, the data, that's what it should be on average. Okay, that's the highest point. But neither one of these exceed that, so we're good. We have no outliers. Okay? Same thing with the value, right? Different set of data, right? IQR, Q3 minus Q1, 22.44 minus 1.7 is 20.74. So now we have the median, right? We have the middle. Our limit is 31.11. Q1 minus the minimum is 1.7 minus 46.52. So our left whisker is 48.22. Max, our right whisker is 21.64. Okay? So the left whisker limit exceeds the limit. There's an outlier, right? So the limit was 31.11, but this is 48.22, so it's bigger than the left whisker. So we have an outlier on the left side, right? This goes back to your question, Bianca, as far as like, there's a side, there isn't a side, it depends on the data, right? So we have an outlier now, okay? Based on our calculations. The most important thing really is understanding the IQR, Q3 minus Q1. And then once you get the IQR, you can go back in and kind of figure everything else out. Going back to the symbology, once you understand the symbology, the next thing is to understand what they're asking for, right? Once you understand what they're asking for, go find the appropriate formula, right? That's the kind of the way I would approach this, right? What's the data I'm given? What are we asking? What's the formula for me to get to that answer? Okay? And then take it from there. All right, so so the skewness here, since 12.39 is less than 20.72, the median is left of center. Okay, so here we have the median minus Q1. We're trying to figure out the skewness. Okay, skewness coefficient is negative, the distribution negatively skewed, right? I'm not worried about the value right now. Again, we got the median minus Q1, 15.25 minus 2.86, 12.39, Q3 minus the median, 36.97 minus 15.25. So now I got my range, right? I got my left and my right whiskers. And so the left whisker, right, is longer than the right whisker. Okay. So this is longer than that. Okay. 12.39 is longer than the right whisker. Skewness coefficient is negative. Okay. So See if they have an example here. I can show you what we're looking at really. Okay, so if you were really to put this in, this is R. If you were to put into R, this is what you would get, okay? And you have to read this, understand. The -20 is our left extreme. 45 or so is our right extreme, right? For this. And the median here is what? What's the median for the value?
15.
15, right? Give or take, something like that, right? And then for the growth, we have -40 as our left whisker. We have 80 as our right whisker, but our median is what? Same thing, right? Our median is about the same. So give or take, yes, you probably get more annual returns on the growth a little bit, but for the most part, they're pretty much the same. Okay. All right. What time is it?
7:02.
Okay. I'm gonna keep going because we got some stuff. Normally I get, unless you guys need a break. Good, good, good. Okay. All right. Geometric mean. Basically, when you look at the geometric mean, you're trying to evaluate return on investment, right? Trying to evaluate, okay, is this am I gonna get a good return, right? It's a growth rate is really what I'm trying to look at, right? How much is it gonna grow? I'm not gonna take you through this formula here because this is not the way we're gonna use, we're not use this formula. We're gonna do something else, but just for a quick sake, right? G here represents the growth or geometric mean, okay? R is just the return. N is the number of years that we're looking at as far as the return. Of course, everybody knows what the square root is, right? And then for this formula, everything under the square root needs to be done first, and then we will subtract one from it, okay? So just keep that in mind, all right? All right, but no, I'm not gonna do that either. Okay. Now, there you go. All right, so ignore all this. Math has a way of trying to show you a bunch of stuff, right? This is the formula you will be using to calculate the growth, the geometric mean, okay? So basically it's n minus one, right? N being the number of years you're looking at. The square root of xn, which is, again, what is xn here? Give me a minute here. Oh, it's the number of the rates for each year. Excuse me. All right. X1, same thing. The rate. Okay, so here you have the years, you have the sales, right? And we're looking for the growth rate after 5 years is 61.5, right? Okay, so basically what we did is we're trying to find the growth, all right? So you take 5 minus 1, which is 4, which is, we'll talk about that in a minute here, right? 16.915, okay? Divided by 13.322. So you take the highest yield in that year, or for that year, and you take the lowest yield that you have, okay? Because again, you're looking for an average, right? You divide those two, you minus one, it gives you this decimal here, okay? So the 5 minus 1, where does that come in play, all right? So once you have done this calculation that's underneath the square root, all right, you have to take that number and find the fourth root of that number. Okay, so there's square, which is the 2, right? There's cubed, which is 3, and there's 4, which is, I don't know, but it's just 4, all right? 3, 5. This number could be anything. Okay, so if you go to your phone,
So it's just because it's 5 minus 1, so that's why it's gonna be cubed.
that's why it's gonna be 4.
That's why it's gonna be 4.
It's gonna be 4. And the 5 minus 1 comes from the number of years. That's your max year, that's your minimum year, right? Max, the return in that year minus the return in this year, right? I mean, divided by the return in this year, right? But use the 5 minus 1 because you need to basically spread it over the 4 or 5 years, right? To really understand what the growth rate is, right? So on average, the growth rate after 5 years is 6.15%, or basically every year your investment is growing by 6%. Okay? So if you go to your calculator, right? And you turn it sideways, well, if you have an iPhone, that is, right? You turn it sideways and you see this sexy thing here. Oh, sorry. You see
Oh,
that right there?
Mhm.
Okay, where it has just the variable, right? Where it has the Y, X, yeah, yeah. Okay, you see
That's
that?
for,
The Y, yeah, with it's just the Y, that one,
This one? Okay.
yeah.
that's
Okay.
derivative, right?
No, that's square root. Yeah, that's square root, right? So, or the root of, let's not say square, because square determines is two, right? So we're looking for the root of this particular equation, okay? 5 minus 1, so if you type in your, if you do the calculation yourself, right? Go to the calculator, do 16,915 divided by 13,322, boom, equals there, okay? And then you press that little button up there, and you press the root that you want, right? 5 minus 1 is 4. Okay? And then you subtract 1 from that. Alright? So don't forget, that 1 is not included in that at all. Okay? It's a separate operation. So whenever you see this, whenever it's not a, basic square root, you'll always see this thing here. It'll be y, and you'll see the square root of n, whatever it is. Okay? That means you can put in any square, any root you want to figure out what it is. So for this particular example, 5 minus 1, because of the years and the appropriate, return, or the return in each year, right? Boom, -1, and then you convert it to a percentage. Bless you.
Thank you.
Okay, you're welcome. Pretty straightforward. Again, the way I would tackle these problems is to, one, like I said, figure out what they want. Two, write down all the information they gave you, right? With the appropriate notation. Three, what's the formula I need to use to get the right answer, right? And then four, what does it mean? All right. All right. We talked about interquartile range already. All right, measure the dispersion. All right. Okay. Variance. Okay. So the variance is the true dispersion that we are really talking about here when we're talking about statistics, okay? So we talk about variance, we're talking about, again, how does the data set vary from the mean, okay? But it doesn't work out the way we want a lot of times, because we take the average here, 25, 30s, and 60, 85. That's 85 divided by 1, 2, 3, 4, 5. Make sure I got the right numbers here. Make sure I got the right math. Yeah, 85. What's this? 1, is it 13? Is that right?
17.
That is 17?
85 divided by 5.
Yeah.
Yeah, 17.
Man, my math is off. Yeah, it's wrong today. Oh yeah, sheesh. Golly. So crap today. Okay, so my mean is 17. Okay. So the variance is basically saying, okay, I know my mean 17, but what is the difference between 17 and each of these numbers within my data set? Okay, because I'm really trying to figure out the dispersion. I'm trying to figure out the spread, right? I'm trying to figure out the average is this, but how far apart are my numbers really from each other, right? So 17 from 5, and this is absolute value. there's no, negatives or, it's just 12. 12 is the difference here, right? And then we got 7 is the difference here. We got 2 is the difference here. 8 is the difference here, and then, what is this? 13 is the difference here, okay? And what you wanna do is, you wanna add all these up, right? And get the average of them, right? But what happens is, if you just do it this way, it gives you 0. Okay, it cancels out every time. Doesn't matter what numbers you have, it just cancels each other out. Alright, because don't forget, this mean is derived from this set of data. So they cancel each other out. So this is when we square everything and we get, instead of having the variance, we have the standard deviation. Okay, because the standard deviation takes the square rooting of this, right? And gives it more impact, right? And so the variance though is what we like to use, right? Because sometimes you'll need the standard deviation, but they will give you the variance, right? So the standard deviation is equal to the square root of the variance. Okay? So from a conceptual standpoint, the variance is just the difference between the mean and each one, right?
Mhm.
But we can't use it because it cancels each other out, right? So we have to square it in order to get the standard deviation, right? That's when we need the square root. Okay? And so once we get the square root, we're good to go. We have the standard deviation is what we need, right? And so we'll get into this formula soon, but the variance is the primary square difference between observations and the mean, right? But it's the primary measure of dispersion that we really looking at, but because it doesn't work very well unless it's squared, we have to find the standard deviation, but in order to distinguish the two, we say standard deviation for one and then variance for another, right? Alright. Alright, so here we go. So if we're looking at the standard deviation, the variance, okay? The variance is equal to the sum of the x, right? Whatever the data point, minus the mean squared divided by n minus 1. Okay, so, and then for the population, Greek symbol, right? Still the same thing. The population variance is equal to the sum of the x's, right? Minus the population mean squared divided by n, right? Or here we have the standard deviation, the population standard deviation is equal to the square root of the population variance. Okay? Again, important to understand the symbology. Once you understand the symbology, you can just plug and play all this stuff. Very easy. All right, once you understand what's going on. All right, so the thing with this is that you have to take each individual data point and apply this formula to it. Okay, so what it's saying is like, hey, because this is what the summation means. So I would basically say 5, right? If I was looking at my data set up there, 5 minus 17, right? Squared divided by 5 minus 1 gives me my first standard deviation, right? My first piece of data. Matter of fact, let's just do it, because that way I think it'd be easier to understand.
Thank you.
No problem. If you need me to do something, just let me know. Alright, let's do this. Let's write out this formula, alright? Another thing is you will not have to memorize the formulas. Okay, you just, doesn't make any sense to try to, I used to know them, but I don't know them anymore. I get it, okay. Alright. Yeah, okay, cool. Alright, so let's just say we have this data set here. Yes.
Isn't this similar to the other slide?
Which one?
It was like. It was kind of like.
Oh, the geometric mean or the growth?
Yeah.
Yeah, the formula is gonna look the same, but they do different things. right? And so that's why it's important to understand what the formulas, what you're looking for, so you can pick the right formula, because they're asking for different things. The geometric mean is pretty straightforward, and just adding up all the stuff. And,
Oh, yeah, and divided by the N.
right, yeah, the years, right? Because then we're looking for growth over time, right? So we have to use the years. This is standard deviation or variance. We don't care about years or anything like that. We're looking for the two pieces of information that we really need to really do real analysis. The mean and the standard deviation.
Mhm.
But sometimes they don't give you standard deviation, they'll give you the variance, right? Which is what I was explaining earlier. When you get the mean, and if you look at each, compared to each individual data point, right? And you get the average of those differences, that's what the variance is, but it cancels out. It gives you zero, so it's useless. So because of that, they square it, right? And that's why you have the standard deviation, right? So the standard deviation is the square of the variance, right? And all the variances is, what is the difference between the mean and each data point? That's really what you're talking about.
What's the difference between?
The mean, the average, and each data point. What's the average difference between the mean and each one of those data points? So what happens is when you start to look at the standard deviation, you start to look at the data, you start to understand that, okay, how far apart are they? Right? And if the average distance is 17, if the mean is 17 and the average distance away from 17 is 5, right? That tells me something that, or it says, okay, if the average distance is whatever the standard deviation is 5, but then I have one that's 10 away, that means it's further away from the mean. So it's further away from the average.
So 5 is the furthest one away from 17.
No, not necessarily. Mm-mm.
Wait, so the standard deviation would be 12 for 17 and 5?
No, no. We're gonna do it right now. We're gonna just calculate standard deviation right now. Okay? So I see where you're going with it, and you got the right thinking, but because it doesn't, it's not something you necessarily want to do in your head, right? Because you have to calculate each one, right? So you're taking each x, right? This is x1, x2, x3, and so forth and so on, right? Alright, so here, this s squared is the variance, okay? And saying, I want you to sum all the x's minus the mean squared divided by n minus 1, right? So the way I would approach this problem is the first thing I'd be like, okay, what did they give me? N is 1, 2, 3, 4, 5. I have 5 data points in my data set, right? That's my n. Okay, so that's 5. Next thing I would say, okay, what are my x's? Well, I have my x's, x1, x2, x3, x4. Okay? So I have an n, I have this variable, I have this variable, right? Because this variable is what? What's this one? What's the x bar?
The weighted average?
No, not the
Oh,
weighted average.
weighted.
It's just the mean.
I'll just mean.
Yeah, the weighted average only comes in when you're trying to give things certain emphasis, like your grades, right? 20% of your grade is the final, so you want to give it 20% times whatever grade you get, right? But if you're just calculating straight up average, it's just a straight up average, which we calculated here, right? 17. So this is 17, okay? So now I basically have everything I need, right? I have my x's up here. I got my x bar here, and I have my n here, okay? And all I'm doing is plugging and playing. But because of this, right, it says add them all up. So you basically have to do the calculation for each one of these data points as compared to the mean. Okay, so what we're gonna do is this. All right, so it's gonna look like this. It's gonna be 5 minus 17 squared divided by 5 minus 1 plus 10 minus 17 squared divided by 5 minus 1 plus 15, excuse me, minus 17 squared divided by 5 minus 1, and so forth and so on. Okay? And then once you do all that, right? That will give you a variance. Okay, so we'll go through it real quick. Plus 25 minus 17 squared minus 10 minus 1 plus, what's the last one? 30 minus 17 squared, then minus 1. Okay. All right, so let's tackle this one at a time. All right. So what's this? What's 5 minus 17?
12.
Okay. 12, right? Square that. Excuse me. So 5 minus 17 squared is what?
No.
Hmm? So 5 minus 17 is 12. 12 squared is 144. All right?
I gotta get the scientific.
Yeah. Yeah, get your scientific calculator out. So if you see a y or x with a square, a superscript, so if it's at the bottom, it's a subscript. If it's at the top, it's a superscript. Okay? So on your calculator, look for something like this.
I put the one that is
That's
X2.
Thank you.
X2, right?
squared.
And what they give you?
4 for the second one, 4.
Oh, for this one?
Yeah.
Okay, let's see. 10
Oh,
minus,
well, I didn't do the over 5 minus 1.
that's fine. So 10 minus 17 is 7. 7 squared is
I did
49.
10 minus 12, my bad.
Oh, you put 10 minus 1, yeah, I want to see. 10 minus 17, right, 7, 49 squared, right? And then 5 minus 1,
Yeah.
right? So it's basically plus 49 over 4, right? So everything stayed the same except for the top number, except for the numerator, right? Because you're calculating it based on, you're comparing every data point to the mean at the end of the day, right? So now we have this, okay? What's this, 2, right? 15 minus 17 is 2,
4.
4, right? Divided by 4 plus, what's this? 25 minus 17 is 8. 8 squared is
64.
64, all right? N minus 1, 4 plus 30 minus 17 is what? 13? 13 squared is what? 160?
169.
169, right? Divided by 4. And then from there, it's just simple math, right?
Yeah.
Okay, so I'm gonna move it up here, okay? So 144 divided by 4 is what?
36.
36? Plus 49 divided by 4 is what?
12.25.
12.25.
1 plus 1.
1,
64 by 4 is.
what's that?
16.
16 plus 169 divided by 4,
42.25.
42.25. Okay, so add that all up.
20 divided by 20, right?
No. Divided by 4. No. So each one, so you don't have to, you already did each one, right?
Yeah,
So all you have to do is add it all up.
okay. So what about the 4? It stays over
We're 4.
the bottom, C divided by,
Oh,
yeah.
the 4 comes from the n minus
Oh,
1.
cool.
Okay? So you did the sum of these, right? Divided by n minus 1. So what is all this added up?
107.5.
107.5. Okay. Divided by 64. Okay,
Wait, why is it over 4?
because we still have to,
Yeah, that's what I was asking.
okay, that's what you're saying. So this is why we don't do it by hand, right? Okay, so technically, we would go ahead and add all these up and then do the 4. Okay?
Oh, because we're still doing the top part?
We're still doing the top part, right? I should have done it that way, but I've been doing it for a while, so I kind of skipped a couple things, right? But just slow it down. Take this part out. do that, okay? So let's add all that up. Okay? And then divide it by 4. Alright? So what do you get when you add all this up?
$26.875.
27.685, right?
26.875.
26, okay. So the standard deviation is, this variance, excuse me, 26.875, right?
Mhm.
Okay. So now we have the variance, right? But we need the standard deviation. Okay, so the standard deviation is equal to the square root of the variance. Okay, so in order to get the standard deviation, we have to find the square root of this, 26.875. What did that give us?
5.184.
Well, that's cool. We'll go 2 or 3, okay? So 5.184 is our standard deviation, right? So on average, each data point is 5.1 units or increments away from the mean. On average. Okay? So what that does is, let's just say our standard deviation is 5, let's just put argument's sake is 5 and our mean is 17. Okay? So there's always a 1 in front of this. Anything you do math, there's always an imaginary 1. Okay? So there's 1 standard deviation is equal to 5. Okay? Now, what if I want to know what 2 standard deviations are? Or actually, you know, let me erase this so we get all of them. Okay. If you, yeah, don't you pay attention. So anytime you see a poll or something or some kind of survey, a lot of times they'll say something like this. 30% of America, loves apples. Plus or minus 5. Okay? That is the standard deviation they're giving you. Okay? So what can you do with the standard deviation? Standard deviation is useful in creating ranges. Creating ranges. So one standard deviation is 5, right? So if my mean is 17, right? If I don't know what below, the lowest point below and the highest point above my mean is, right? Plus or minus 17, right? 5 plus or minus 17 will give my first range. Because this is my standard deviation. This is the average distance that each of the data points are from the average. So it's kind of play on words. The average distance that the data points within my data set are from the mean. But now my range, so if someone would say, look, what's your range for your one deviation? It'd be, 17 plus 5, which is 22, 17 minus 5, which is 12. Okay, so now one standard deviation away is between 12 and 22, right? So any numbers that are in this group and between 12 and 22, they're within one standard deviation of my average. Okay? You can take this and say 2 standard deviations, which would be 10, right? It's basically 2 times 5, right? So you go 10 plus or minus 17, right? So basically it'd be 27, 7. Excuse me. Okay? That's 2 standard deviations away, right? And so forth and so on, right? You got as many standard deviations as you want. Now, where does this make sense at? Remember our bell curve? Okay, remember our sexy bell curve right this right here? 0, 1, 2, -1, -2. Okay? These are standing deviations. Right, at the bottom, alright? So. What we're saying is that 12 and 22, right, is one standing deviation away. So basically between 12 and 22 are gonna fall somewhere in here. Okay? This is two standing deviations away. So the numbers are gonna fall between here and here. Okay, it's gonna take up 95%, right? And so what we're trying to do is, we're trying to exhaust or encompass the entire data set and understand where does the entire data set fall, right? If we look here, right, 3 standard deviations is equal to 15. Okay, so if we take 15 away from 17 is 2, plus to what, 30, what is that, 32? Yeah, 32, okay, so 2 to 32 is equal, 15, excuse me, plus or minus 17, 2 to 32. Okay, that's 3 standard deviations away, right, which is out here somewhere. But if you notice, it's covered all the numbers within your data set, okay? Because this is basically 100% out here, right? On one, you got the whole bell curve covered, right? You have the whole population covered. As far as, hey, all my numbers, I know exactly where they fall within my particular bell curve, all right? I'm going to erase all this. We are gonna go do it one more time because we're gonna need this to do z-scores. Okay?
Z-scores.
Z-scores, yeah. So z-scores are basically the same thing, right? And the z comes from the word standardization. They just took the z out, right? And z-scores are just, we're focusing on one particular data point. That's all. So this is how you get individual standard deviations. So for instance, if I just wanted to know, where you fell within the bell curve, right? And just say, we had, something like this. All right, and just say we had a bunch of test scores. And I wanna know, where do you fall, where does your score fall in the class, right? Is it for 1 standard deviation from the mean, 2 standard deviations from the mean, 3 standard deviations from the mean, are you below or above average, right? So, like we talked about last week, right? Most classes for STEM classes are weed out classes. Right, I was telling the class last week, I had a 30% in my physics class, right? But I still gotta be out the class, right? Because that's how we set curves, is to standard deviation, right? So let's just say the average score in the class is 50%, right? And the standard deviation is 10. Okay? So there's a couple of things that when you look at this that you should get, right? So understand that this mean is the same thing as this. It represents, this 0 represents this 50 because it's your starting point, it's your average. Okay? Now, the standard deviations, right? Think of this as being 10 increments. 10, 20, -10, -20. Okay? So we have the raw data here. We have the standard deviation here, right? And we have the differences here. And so just by looking at the numbers, right, 15, 10, right? If I want to know what one standard deviation is from the mean for this particular set of data, right? What would it be? What would one standard deviation be?
-10.
Well, yeah, you're right about that. But as far as the raw data, like the score, like if the 50 was my average, what would be my next, what would be the B? So let's just say the 50 is the A. What would be a B? Or what would be a C?
Like 60 or 40,
40? How do you get that?
I just did -10.
Minus 10, right? Because this one standard deviation is equal to 10. Think of the standard deviation as increments. Okay? They're just telling you, hey, you are 10 steps away from the mean on average, no matter which data point you pick. You're probably 10 steps away, 10 increments away. So if you want to know what deviation or where this person falls in, right? If 50 is my starting point or my zero, right? And my standard deviation is 10, that means the next score is 40. The next one is 30. This is 60, and this is 70. You understand? So now, this right here becomes kind of like my C, because it's my average. Okay? This is my A, this is my B, this is my D, and this is my F. No. No, didn't help any.
No, that makes sense.
Kind of sort of
I'm confused.
confused. It's okay. All right, let's try this again. All right. Let's just take a simple data set. 5, 10, 15, keep it simple. Okay, let's calculate the average for this. What's the average here?
10,
10? We sure?
7?
7?
No.
No, 10.
10?
Yeah.
Yeah, 30
Yeah.
divided by 3, yeah.
Right? So the average is 10, right? What's the standard deviation here? Well, let's go to our formula. All right, so our standard deviation, all right? And there's an easier way to do it. What's the formula of standard deviation of it? Oh, with the variance squared, whatever. All right, so let's use the variance squared. I mean the variance first, okay? So we know that the variance is the x, which is my data points, minus the mean squared divided by n minus 1. Okay, oh, summation, excuse me, that add all up, all right?
wait, what is the variance specifically? Is just the sample of what we're looking at?
No, the variance is basically the difference between the mean and each data point and taking the average of those differences.
I thought that was the standard deviation.
It is, but it's the standard deviation, square, it's the square of the variance. Because if you take the variance alone like that, it cancels out, it just gives you a 0. So because of that, we square it, and that gives you the standard deviation, all right? So you're on the right path.
I don't know.
You're on the right path. You're understanding it. So basically, we're calculating the variance, but once we get the variance, we take the square root of it to get the standard deviation.
Okay.
Okay? Because we're really looking at, okay, what is the dispersion between here and here? Here it's 5, right? Here it's 0, and here it's 5. Okay? And then what we're doing is for the variance, we're basically taking the average of these, right? And calculating the variance. But because it's gonna, if you do this, right? So let's just do it, okay? 5 plus 0 plus 5 is 10, right? 10 divided by 3 is what? 3.3 something,
Right.
right? Okay, that doesn't work. Can't do it, right? So what we want is really, okay. So we want to get the variance, but we want to go ahead and do it for each one, right? So again, all right, we get 5 minus 10 squared plus 0, why did I put, no, 10, excuse me. 10 minus 10 squared plus 5 minus 10 squared all divided by n minus one. Okay, our n is equal to three, right? Because we have three data points, right? Okay. So this is gonna give us the variance. But once we get the variance, we want the standard deviation, which is equal to the square root of this.
Okay, and you wrote n minus one, but only wrote three.
Oh,
You
shit.
need two, right? But you would do everything at the top first and then divide it by two.
Mhm. Yeah,
And then once you get that answer, you square it, and that's your standard.
that's your standard deviation. You take, no, you don't square it, you take the square root of it.
Okay.
Yeah, you take the square root, because we're squaring it now. You see where we're squaring it here?
Mhm.
Alright, so this would be, let's move it down here. 5 minus 10 is 5 squared is what?
25.
Plus 10 minus 10 is 0, 0 squared is 0. And then 5 minus 10 again. 5 minus 15, excuse me. 5 minus 15 is 10. 10 squared is what?
100.
100, right? Divided by 2. Okay, and then we move down here. So we got 125 divided by 2. And then what?
62.5.
62.5. Okay? So that is our variance. Okay? But our standard deviation
7.9.
is the square root of this, right? 5 equal to what?
7.9.
And
So
49.
when do you round? Like you only round if they tell you to round?
Yeah, so usually you want to round, you do
Okay.
2 digits. But if it's need more precise, they'll say. Okay, so our standard deviation is 7.9. So what we're saying is that on average, the mean compared to each individual data point is 7.9 increments away from the mean.
Okay, the mean compared to 5, 10,
15,
15
right,
is 7.9.
right. It's the average distance away.
Okay.
Okay, this is the average distance away. It's not gonna be specific, like exact, but on average, if you try to get from one number to the next, it'll be 7.9.
Okay.
Okay, so what this helps us do is, because now we know what the range is, I mean, the deviation is, we're just gonna round it up to 8, okay?
Mhm.
So the question is gonna be, what is one standard deviation? One standard deviation, right? What's the range for that? So it's plus or minus 8, 10, 16, plus or minus 10, 24, plus or minus 10, okay? One standard deviation, two standard deviations, three standard deviations. Okay? So the standard deviation helps you build ranges based on the mean. Okay? So that when you look at it, one standard deviation away, 8 plus, 10 is 18,
Wait, why are we doing that now?
because we want to know what the range is for one standard deviation. Like if I was trying to figure out, okay, how many data points fall in within one standard deviation of the mean?
But you said the standard deviation is just the distance between two data points.
No, it's the average distance between
Okay.
all the data points.
Okay.
You see what I'm saying? So it's this here with an 8 is the average distance between,
5 to 10, 10 to 15. Okay,
Right.
and the range is trying to figure out the middle between 10 and 15.
no, the range is basically, we're just trying to figure out the range, like what's the range it falls in? Right? So the first range, which is one standard deviation, would be basically, because we know the standard deviation is 8, right? We have to get the below and the above from the mean. That's what we're looking at, right? Because again, this is our average.
Mhm.
or 10, right? But what's below average?
Okay.
What's above average, right? So we know one standard deviation, right? Away from the mean, that will give us
8.
8 plus 10 or 8 minus 10. Because this
Oh,
whole-
because you're either going 10 forward or 10 back.
you either
the
no,
next-
you're either going 8 forward or
Oh.
8 back.
Oh, yeah, you're, okay, you're going 8 forward, 8 back.
Right, you're going either 8 forward or 8 back,
Okay,
okay? One standard deviation
from 10.
from 10. It's all about the mean,
Mhm.
okay? It's all about the mean. So that's one standard deviation. Two standard deviations, I'm going 16 forward or 16 back from the mean.
Yep.
Three standard deviations, I'm going 24 forward or 24 backwards from the mean,
Okay, no.
okay? Yeah, it's still question, so,
Oh, so, yeah,
which part?
I think when we got to the 15, the 8 plus 10, like I don't know where the 8 came from, cause I know that's the standard
Okay,
deviation.
yeah, so the 8 is standard deviation, right? And all I'm saying is that we are 8 increments away from the mean, right? Give or take, right? So if I see with 8 increments from the 10, so that tells me 8 minus 10 will give me 2. 8 plus 10 will give me 18. So that's one standard deviation. So any number that falls within this number, within this range here, that's in my data set, is one standard deviation away from the mean.
And you would be able to like plot this, right?
You wouldn't plot it, you would do it, you
Like
do.
that box thing? Oh, okay.
Yeah, you would put it on a thing like this,
Okay.
right? Something like this, right? This is 0, this is 1, this is 2, -1, -2, okay? So this is standard deviation metric, right? But understand that all this is representing is the raw data. 0 is the theoretical mean. That's your starting point. You always start from 0, okay? So for us, our 0 is 10. Because that's the mean, that's the average, right? From there, how do I calculate below average? How do I calculate above average? I need to know the average dispersion, which we already did, which is the 8. Okay, so 8 is my number to create my ranges, right? So if I want to know how many of my data points fall within one standard deviation of the 0 or the 10, right? So 10, 8, yeah, 10 minus 8 is 2, right? 8 plus 10 is 18, okay? So the next one is 16. 16 minus 2 minus 10 is 6, all right? Oh, -6, excuse me, all right? And then this is, what, 16, 26. Is that right? 10. Yeah, -6. Okay? So now you have your ranges, right? So if I say one standard deviation away from, what you call it, from the mean, right? That means that my numbers should fall between 2 and 18, right? Which they do. So I know all these numbers are within one standard deviation of the mean. It's one standard deviation of the 10. Okay?
Mhm.
This becomes useful when you're trying to figure out, okay, what's below or above average and how far away are we from average, right? So let's go back to the height. If the average height is 5'6", I'm 5'10", okay, I'm not too far, I'm above average, but I'm not too far away from the average, right? But again, if we go with Shaq, 7 feet tall, he's way off the average, right? He'd be over here somewhere.
So if I'm like 6'1", am I close to the average?
You're not close to the average, because the average is 5'6", right?
Okay.
You might be 2 standard deviations away, you might be over here somewhere. Okay, you might be getting close to what we call, right? Above, below. You're above average.
It's not an outlier though.
You're not an outlier yet. No, Shaq's an outlier. But the outlier is dependent on the data set, okay? Everything's dependent on the data set. You don't get it fixed like there's a concrete or fixed outlier or fixed mean or anything like that. All this stuff is based on these numbers here. Okay, all the data, everything you're doing is based off your data. That's why it's important that your data isn't skewed, that it's normally distributed. Okay,
So you always start off with that formula, basically?
yeah, if you're looking for the standard deviation, yes. Mm-hmm. Yep, you're looking for the standard deviation, you'll start with this formula, right? This is, you know, again, this, of course, this is the standard deviation formula, right? Standard deviation equals the square root of the variance, but you gotta know how to calculate the variance. So.
And
okay.
Excel does that?
Yeah. Excel does that, alright? But I don't want you guys using Excel just yet. Alright, kinda want you guys going through a couple iterations of this and trying to figure it out a little bit, alright? Okay, I'm not gonna do any more because there's a whole nother 30 slides with the stuff. Alright, that needs to be done. What time is it?
7:32.
Okay, yeah, going way too late. Alright, so, what I'm gonna ask is, do as much as go take a look at the PowerPoint. Try to understand as much as you can, okay? And then for this week's assignment, do as much of it as you can. On your own, not using Excel or anything like that. Alright, there's one of them that's gonna say use Excel, which is fine. I think it's one of the growth ones, growth rate. But do as much of it as you can. Okay, based on what we've got so far. And then what I'm gonna do, I'm gonna extend the content till next week and I'll catch up down the road. Okay, so, go home, look up until slide 35. Okay, review that and then go past that. There's 20 more slides or so of content. Review it, look at it, but we're gonna go over it in class next week.
Okay.
Okay, so don't trip, don't worry. Same thing with the quiz. Do what you can of it, and I'll adjust the grades from there. Okay? Or maybe I'll wait and let you do the quiz next week and you just have to take 2 quizzes, maybe.
We didn't go over the coefficient of variation.
Yeah, I know, yeah, that's down a couple slides,
Okay, okay.
yeah.
So we just submit an assignment with like. Not answering that
But that,
variation thing, the coefficient.
yeah, just do the questions that you can based on what we've done so far in class, right? And then next week, by all means, if you feel like you wanna tackle all of them, go ahead. But I'm not gonna penalize you for having the wrong answer on it, is what I'm saying.
Okay.
So do as much as you can, and then next week, we'll continue on with this, right? And then for the quiz, either you can go ahead and take it Sunday if you want, or you can wait till next week and just have to take 2 quizzes. Okay, it's up to you. But if you decide to take the quiz this week, you don't get a good grade, don't worry about it. I will fix it, I'll adjust it, alright? I just want you to go in there and kind of give it a try, play with it a little bit, cause you have to really like do it to really understand it, right? To get into it. Me explaining it here, the fire hose, you know, there's a lot of concepts here that take time to really absorb. So I understand that. So go home, look at the PowerPoint, review it, take a stab at the LE, take a stab at the quiz, and then we'll continue on next week with the rest of it, and then we'll review again. Okay? Because we'll have time to catch up on some other stuff down the road.
Okay.
Good?
I do have a question on
Yes, ma'am.
how to do the OE.
Okay.
So we have to do a PowerPoint and record ourselves and submit that.
Yeah, I forgot about
Yeah,
that.
it's like week 2.
That's something new. And I'm not really like used to it. So what do they want you to do?
You gotta record a video basically just answering, but you just make a PowerPoint and you could like just record yourself talking.
Mhm.
Yeah, basically just doing the LE, but you're just making a PowerPoint.
You just
And they
make a
usually
PowerPoint.
say we don't have to answer Like, we don't have to reply to our classmates when we do.
Okay, so follow the prompt. Okay, do the PowerPoint. And you can do it one or two ways. You can speak to what you're doing, or you can actually do the calculations, take a picture of it, upload it as a PowerPoint slide, and submit the PowerPoint that way.
Do the calculations.
Do the calculation on a piece of paper or on a Word document, and then upload it into the PowerPoint.
Do we have to make a video of us explaining how we did?
Right, yeah, just do a video explaining like, okay, this is what I did step one. I found the variables, I found the end, the X's and that kind of thing. And I used the formula for standard deviation. And then this is what I came up with. And then you kind of have everything laid out on the Word document or on the slide if you want, right? And I can see the calculations and everything, but you're speaking to it. So just like I did today, hey, I added this and that, and then I divided it by n-1, give me this answer, which means that, the standard deviation is this,
Okay.
okay? So kind of walk through it, explain it to me on the PowerPoint.
So this learning engagement, which is supposed to be due today, is due on Sunday.
Sunday, yes,
Right, the video is due on Sunday.
Sunday,
Cause it gives us some time to.
yeah, give you something to kind of figure it out.
Yeah, when I was taking business calc, at San Diego Miramar College, the community college. We just, briefly touched on this in the bell curve,
Yeah,
but we were more graphing.
right, there's more graphing and calculus, yeah.
Deviations and all that stuff, standard deviation.
Yeah, your calculus is mostly graphing, not, you can figure out derivatives, integrals, all that.
But this is more complicated than that.
Oh, no.
So for
No,
week 2's assignment,
I'm just confused.
you have to access the textbook?
Yeah, you guys have the textbook, right?
No, I was
No?
gonna ask, if you wouldn't mind guiding me to it.
I don't know how you guys get your textbooks. How do you guys normally get them? You should have an e-copy.
I think it's usually mostly like PowerPoints.
Is it?
Yeah, the PowerPoint. My friend found the PDF for another class, but I don't know about this one.
I would send an email to Dr. Wara or to whoever your point of contact here is, to ask them, hey, I need the book. You should have access to the book, okay?
To submit that, because there isn't like a submission button.
There's no submission button?
Like
For
it
what?
says it's our assignment, but there is nowhere to submit it. So is it really like an assignment or is it like an extra, like,
What
What is that?
engagement?
no, the reading assignment, like the
Oh.
listen to assignment?
Oh, no.
The reading assignment?
No, it says listen to assignment.
Wait, can I say?
No. Don't worry about lesson 2. That's just something else. Yeah, that's just,
Yeah.
it should be LE, it should be learning engagement.
Right here and right here.
Yeah.
Oh.
Yeah, the learning engagement is what, yeah.
Okay, thank you.
Over it. Sometimes it's stuff on the courses because the courses get passed around from instructor to instructor. Some instructors add stuff, take stuff out. And that stuff is useful, but the learning engagement is what you need to focus on.
And we have access to Zoom on our stuff too, right?
Mhm.
Through the portal?
Yeah.
I will post the Zoom.
Yeah, usually we have to wait for them to.
Yeah, I'll post the Zoom.
No, I mean like the Zoom for us as students, like through the.
No, I don't think so. You can do your own personal one.
Yeah.
What, we're trying to record the video?
Yeah.
Do it
You can
online.
do that on Canva. Do it on Canva.
Yeah, Canva, PowerPoint, yeah, do PowerPoint.
PowerPoint is very easy.
Yeah, you just record.
Yeah, exactly.
Canva is like.
Julio, you good?
Yeah, I was listening to everything. So Sunday is the due date with a PowerPoint, a video like normal.
Yeah.
And I was,
Do the best you
so
can.
is it just the LE or is there extra work that to do at the end of this week?
No, this is the LE. This is the LE.
Okay. All right, I was getting a little confused there for a second.
Yeah. Okay, yeah, just give it a go, see how far you get.
You got Microsoft Word, right?
All right, sounds
Okay.
good. Thank you.
No worries.
I would say
Where's
like,
the school?
you could download Canva. Canva doesn't need anything, just download. I mean, you don't need to
Yeah, I don't
download it.
need
Just go to search Safari.
Does the school offer like
And then go to-
Microsoft though?
It should, yeah,
Yeah,
it
it
should.
Search Canva.
You should?
Yeah,
It
but
should.
then you need Microsoft Word
Yeah,
though.
you
No,
should.
need-
For what?
Or you can get a,
Just in general.
you can
to
go,
type stuff.
But Google Docs is free.
Yeah,
Microsoft
Google
Word
Docs-
is
Yeah, I
expensive.
mean, yeah, if you wanna use that too.
It's like $70 for
you
year.
could, if you go to Microsoft, they should have a free student version of the whole Microsoft suite.
Yeah, cause I don't pay monthly for
Yeah.
Microsoft Word.
No,
or
it's
something.
simply-
But the school should have some kind of resource for you to get that.
Thank you guys. Yeah, that's all I see.
Let me, I'll ask and see, so next week, I'll probably give you an answer as to,
Do we have to take like attendance or sign our name?
you know what? No, I got you guys. Yeah.
Thank you.
All right, okay, I'll see you guys next week, all right? Give it a go. Try your best.
Okay.
Don't be scared, all right?
All right, that's.
All right, see you later.
Take care.
Yes, ma'am. Any questions, email me, okay?